prefer to watch it from YouTube can also view it. So this is what we're going to do today. We are going to go through the exam from fall 2021, and I'm not even going to use the phrase practice exam, because that kind of implies that the format will be preserved in this exam, that there's any type of resemblance. So I'm not going to call this one a practice exam. I'm just going to call this one the exam of 2021 fall, which is extremely factual. That's exactly what it is. We got about 5 minutes. All right, we are getting more people in now. We got 4 people out of a class of about 30. I think it's still close to 30 people in terms of enrollment. Well, since you guys are here, let me ask you a question. You don't have to answer, but if you have an opinion and you want to let me know, you can certainly respond to it. The question is, between online classes and face-to-face classes, do you have a preference? Just in general. Oh, okay. So that's I just got a text from another class. Or is it this class? I cannot remember. All right, so let me take a look at the text. Quick question: will classes be held on Thursday? I believe it is. I don't know. I don't think it is a holiday for us, but I will certainly double check. Okay, let me check it right now. The quickest way to check it, well, at least in my case, is to type, American River College academic calendar. Academic calendar. There we go. And there is one for spring 2022. Just click that one. And this is really annoying because it asks me every single time. And no, you cannot help me. I already know what I want. Thank you. Alright, so we just need to take a look at the holidays. And we do not have a holiday on Thursday. Thursday is not a holiday for us. We got spring break from April 11th to the 17th, but otherwise we do not have any other holidays. Alright, so there is that. And then Luke said, it has been so long since I've had in-person, it's hard to say. I remember preferring in-person. Alright, so that's interesting. Alright. So I am going to move back on campus in the fall. So I'm going to move both of my classes, CISP310 and also CISP440, to be fully face-to-face on the ground. That's just my preference. Being able to see people face-to-face is kind of important to me. And being able to answer questions in an interactive way in a synchronous mode is also important. Now, I know you guys are all doing that right now using the text channel, but I think it's not the same, when we are in the classroom. Besides, the way I'm teaching, I can still have Discord up and running. If you are in the classroom and you prefer not to raise your hand and use your voice to ask a question, you can still Discord me, even though the class itself is face to face. So that's sort of interesting, right? Exactly. And I have an office too. I have an office on campus. It's going to be on the same floor in the same building for once. Um, so when it's pouring or when it's super hot outside, I don't have to go outside to go to my classroom. Isn't that nice? And the break room is right next to my office too. So that's an incentive for me to get back on campus. All right. Yeah. So there's that. I know a lot of people do prefer not to be on campus, and that's why it's difficult for some of my colleagues to move their classes back on campus as much as they want to do it, because enrollment is going to be dismal for on for face-to-face classes, for those specific face-to-face classes. So in order to compete for enrollment, these professors really don't have much of a choice but to remain online. So it becomes kind of more of a chicken and egg problem. All right, looking at the time, we only got about 30 seconds or so before we get started again. And I think having an office, after class or before class, if people really do have questions, they can come in. We can work out things on paper, or whiteboard or whatever. I think that helps too. Doing that stuff online is a little bit more challenging. But this Discord is doing pretty good. I mean, at least we got the equation stuff up and running. So there is that. Alrighty. All right, it is noontime, and I am going to get started. All right, so there's a link to the shared document for today. I did not pin it, so you have to kind of scroll back a little bit. It is the exam 2 from fall 2021. And once again, I am not going to call this a practice exam. I'm just going to call this what it really is, which is the exam 2 from fall 2021. All right, and it's a live document, which means as I type the answer, if you just kind of put your browser on that link, you'll be able to see all the editing as I go. All right, so we're going to get started here, with question number 1. Relation R is blah 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 is defined over X, which has 0, 1, and 2. Define relation R in the following terms. True or false, do not leave blank. So the following term is already listed here. Okay, let me scroll down just a little bit. So it's already listed here. I want you to tell me whether it is reflexive or not, whether it is symmetric or not, whether it is anti-symmetric or not, whether it's transitive or not, whether it's comparable or not. And you would see that certain properties are missing entirely, like partially ordered or totally ordered. They're missing entirely here because those are too easy, okay? Because if something is reflexive and it is anti-symmetric and it is transitive, then it's partially ordered. I found that that kind of question doesn't really test whether people understand the concepts or not, and therefore I don't even bother to ask it. Okay, but there's more. For example, if a property, let's call it UUP, which stands for utterly useless property, is true if and only if for all EF in X, ERF, and FRE. So note that this is not comparable because comparable has an OR in place of the and here. Okay, so this is just something I just made up in just for this explanation. And you find that when E equals to 6 and F equal to 7, only 6, 7 is in R but not 7, 6. Then your answer should state when E equals to 6, F equals to 7, ERF and FRE is false because 7R6 is false. Therefore, the relation is not UUP, or UUP is not true for that relation. So it's a long thing to write. But you can kind of shorthand it if you want to, because we don't, all of these words. Therefore, the relation is not blah blah blah. You can shorthand it a little bit. All right, so let's see what we can do to in this specific question. So the first one is it reflective? And in order for it to be reflective over a set of 0, 1, 2, we need 0, 0, 1, 1, and 2, 2 to be there. So in order to answer this question, it is not enough just to say false. Okay, you have to kind of explain what it is missing. when okay, so let me get back to the module of relation. So that's important because we want to use the same terms to answer the question. All right, so let's go to relations. There we go. So you probably want to have the links to the modules available, like, really handy, so that way you don't have to spend the time to look up these things. All right, so here's the relation. Here is the definition of what is reflexive. For all E in X, E has to be in R. Okay, so in this case, so let me get back to the question here. So in this case, we have to say, what is false, right? So we have to say, when, okay, so you can shorthand it. You can basically say E equals to 1, 1, 1 is not in R, therefore not reflexive. All right, so that's one. Next one is symmetric, whether the relation is symmetric or not. And you can see that it is not symmetric because, if it were symmetric, if 0, 1 is here, then we should also be able to find 1, 0. Now you might say, but that looks like this utterly useless property, but that's not, okay, because this one has an and here. The other one is a if and only if, okay, which is different. So in this case, we say, E equals to 0, F equals to 1, 0, 1 in R, if and only if 1, 0 in R is not true, and therefore the relation is not symmetric. There we go. All right, so you can kind of see, how I am using the definition of symmetry here to answer the question. So that means, you really kind of need to be able to find the definition of these properties, because in symmetry we say for all E and F in X, EF in R if and only if FE in R. But when E equals to 0 and F equals to 1, this if and only if is no longer true, because EF in R is true, FE in R is not true, and therefore the if and only if is false. So that is how we answered that question, or that portion of the question. So now we move on to anti-symmetric or anti-symmetry. So anti-symmetry means if you have both, EF and FE, in R, then E and F must be the same. So we'll see whether we have any way to show that this relation is not anti-symmetric. And the answer is nope. We don't have a way to show this is not anti-symmetric, so we just have to say it is, or you can just say true. Okay, just to save time, you can say true. All right, let's see if it is transitive. So transitive has 3 variables, E, F, and G. EF in R and FG in R implies EG in R. So we'll take a look at this relation and see if that is false. Well, I just found a case where it is false. If you make E equals to 0, F equals to 1, and then G equals to 2, then the relation can be proven to be not transitive. Alright, so we'll go ahead and do that. E equals to 0, F equals 1, G equals to 2. In this case, 0, 1 in R, and 1, 2 in R. But when you use it to imply, because both of these are true, so that means the conjunction is true. But when you say, this implies 1, 2 in R, the implication itself is false, and therefore hence not asymmetric. There we go. So if you want to save a few keystrokes, instead of saying therefore, you can use hence, because that's saving you 4 keystrokes right there. All right, last one is comparable. Okay, thus. Okay, fine. Thus. Okay, you can also use there's a symbol you can use for therefore thus. I cannot remember, it's three dots, but I cannot remember whether it's a triangle with a base downward, or whether it's a triangle with a base facing upward. It's one of those two. I cannot remember which one because I don't use them. All right. All right, comparable. So comparable is definitely not true, okay, because E equals to 1, F equals to 1, 1, 1 in R is false, thus not comparable. There we go. Base down. Okay, thank you. Thank you, Mohammed. It's base down. So that symbol can probably be entered using insert symbol. Yeah, by the time I find out how to do this, it's going to be slower than otherwise. Just spelling out thus, right? Yeah, so for those of you who really are obsessed with using the symbol, you can go ahead and use it. There you go. Chris has gotten it. So since Chris has it here, I'll just go ahead and copy and paste it into here. Oh, it doesn't work. It doesn't work here. Okay. We'll just say this. Oh, it's the color thing. Okay. So, so I just need to fix the color thing because it actually preserved the text color in Discord, and therefore, there you go. All right. Yep. Thank you, Nathan. I just realized it was just different color. All right. Question number 2. Okay, so question number 2 has a different nature. Given that x equals to 0, 1, 2, can you come up with an example of a relation R defined over x such that R has the following properties? It is partially ordered, it is not comparable, and it is not symmetric. If no such R exists, explain using the quantified qualifying statement of relation properties, referring back to the definitions here in the module. So using those terms, explain why it is not possible. There should be a conflict somewhere if such an R does not exist. Your answer should show your understanding of the relation properties and the reasoning based on these properties. Okay, so let's go ahead and see if it's even possible. Alright, so the first thing is we need it to be partially ordered. So partially ordered means it has to be at least reflexive. So that means R needs to have certain elements for sure. Okay, so we know 0, 0, 1, 1, and 2, 2, they all need to be here. In addition to that, we want it to be not comparable. That's easy. Okay, so I'm not too concerned about being not comparable. We also need it to be not symmetric. Okay, so right now it is symmetric. Okay, this is symmetric. So to break the symmetry, I just need one extra term here, like 1, 2. That will break the symmetry, and it's not going to break any of the required properties. So in other words, if you look at partially ordering, is it still partially ordered? Let's check, right? Is it still reflexive? Well, once it is reflexive, you can add more stuff to R and it's always going to be reflexive. So that's not a problem. Next one is it anti-symmetric? Well, since I don't see anything, 0, 0 is going to work out fine. 1, 1 is going to work out fine. 2, 2 is going to work out fine. 1, 2 is going to work out fine because there's no 2, 1 here. So if there's no 2, 1, that means the left-hand side of the implication is going to be false. And as a result, the implication is going to be true regardless of what is on the other side. Okay, so that's going to work out. Is it still going to be transitive? So that's a little more tricky. Okay, so as it turns out, it is still transitive. It's not a problem just by adding 1, 2, to the relation. So that means it's still partially ordered. It is not comparable because 0 and 2 are not related in any way. Okay, 0, 2 is missing. 2, 0 is missing as well. So it is still not comparable. And it is not symmetric because 1, 2 is here, but 2, 1 is not. So now we have an answer. It's just that. All right, moving on to question number 3. So question number 3 is like question number 1. I just kind of mix and match the types of questions. So now we have to kind of go through the same thing. We first answer whether this is reflexive or not. X has 0, 1, 2, so we have to be very careful because let's not assume X is always the same across all the questions. Even if it does, you still want to double check, right? All right, so we want to make sure that 0, 0, 1, 1, 2, 2 are all here and 2, 2 is missing. So we will say, when E equals to 2, 2, 2 in R is false and does, okay, or better yet, therefore, not reflexive. There we go. All right, next one is symmetry. Okay, so is it symmetric? 0, 0 is not an issue. 0, 2, 2, 0. Okay, so we got 1, 0, and 0, 1 is missing. Okay, there we go. So we just found our counter example. When E equals to, what was it again? 1, F equals to 0, then EF in R, let's see, this is symmetry if and only if FE in R is false, and therefore, it changes the color back to the gray. All right, fine. I have no idea why it decides right now it decides to change the color again back to the gray color, which is what I copied from Discord. So we'll just say thus not symmetric. There we go. Next one is anti-symmetric. So this one is not anti-symmetric. Oh, okay. It's holding the color formatting when I copy and paste it from Discord. Oh, well, I did copy and paste it here, the first time it did successfully copy and paste. Okay. Right, okay, so it's inheriting the color from what it was overwriting. But if there's nothing there to begin with, it would basically, carry its original color. Okay, got it. Inheritance, right there. Okay, object-oriented programming. All right, so anti-symmetry. With anti-symmetry, we got 0, 2, and 2, 0 here, so it is not anti-symmetric. So now we say if E equals to 0, F equals to 2, then EF in R. Now, if you want to really shorthand this whole thing, you can even say this, right? ERF and FRE is true, but when implies E equals to F is false. So the entire implication itself is false. So you can just say that this entire thing is false, thus not anti-symmetric. There we go. All right, is it transitive? All right, so with this one, we kind of have to spend a little bit of time to see. It is not transitive. I can see it right away. Because of 0, 2, and 2, 0. Let's see, which way do I want to do this? Oh, right. Okay, so we want E to be 2, F to be 0, and then G to be 2 again. So if that is the case, then E, R, F, and F, R, G, and we need to put parentheses around this because I need to show the implication is false. So E, R, G is false. This implication is false. Thus not transitive. There we go. Transitive. All right. There we go. Is it comparable? Well, it is not comparable also because of 2, 0, and 0, 2. Oh, wait, no. That's not it. That's not it. It's right next to it because 2, 2 is missing because 2 does not relate to 2. So E equals 2, F equals 2, ERF or FRE is false. Thus not comparable. There we go. All right, so I think are you guys kind of understanding the format of what is being required here? All right. So Danny said, seems that a lot of relations won't be comparable unless they have a lot of terms. Um, you can probably figure out the minimum number of terms in order for a relation to be comparable, because comparable means it has to relate to every other element. So you're looking at, guess what? The square, right? Because every element has to relate somehow to every element. And I was about to say every other, but that was actually wrong, because it also has to relate to itself. So that's why you need to have 9 elements in R minimum in order for the relation to be comparable. So there you go. All right, moving on. Question number 4. Question number 4 has the same format as question number 2. So let's see what we need to make it this time. So Nathan is correct, in terms of, R has to be greater than or equal. I mean, the cardinality of R has to be greater than or equal to the cardinality of x squared. But it is possible to, let me see, is it possible? Yeah, so it's possible to have the cardinality comparison met and still not to be comparable. So you have to be super careful not to use that to imply R is comparable. It is the implication goes the other way around. Okay, R is comparable implies the cardinality of R is greater than or equal to the cardinality of x squared. So, right. Okay, so excellent. It cannot be less than that. It cannot be less than that. No. Yeah. So it cannot be less than the square of the cardinality of x. The cardinality of R has to be at least the cardinality of x squared, if R is to be comparable. All right. But in the proof, in the exam, you cannot use these, shorthand, conclusions. You still have to point out, what is missing that is causing it not to be comparable. All right. So question number 4, we want it to be not reflexive and not anti-symmetric, is transitive and is not comparable. And we also want it to be symmetric. Okay, so that seems to be a pretty weird combination, right? So we'll go ahead and try to construct one. Not reflexive is easy, okay? Just make sure you don't have 0, 0, 1, 1, and 2, 2 all being there. If you're missing at least one of those 3, then it's not going to be reflexive. That's an easy one. We want it not to be anti-symmetric. So that requires, okay, let's just say 1, 2, 2, 1, because having both of these, in R will make it not anti-symmetric. We want it to be transitive, so right now it is transitive. And we want it not to be comparable. It is not comparable right now, because you can see 1 does not even relate to itself. Okay, it cannot be comparable. And also we just kind of pointed out that in order for R to be comparable, the cardinality of R has to be the cardinality of x squared. Okay, and this is not even close. And the last one is symmetry, and it is symmetric right now, so this R is meeting all the requirements. So there goes question number 4, and moving on to question number 5. It needs 1, 1, and 2, 2 to be transitive. Yes, okay, Luke is correct. I completely forgot about that. So it needs 1, 1, and 2, 2 to be transitive. Because otherwise, if I make E1, F2, G1 again, then I can prove that it is not transitive. So we also need 1, 1, and 2, 2 to be there. Thank you, Luke. You're correct. And I'm going to give you a kudo in the text channel. Very good. All right, so question number 5, same kind of format. We need to come up with an R to meet certain requirements if it is possible. All right, so this time we need it to be not reflexive. Easy, okay, because the empty relation is not reflexive. We want it to be anti-symmetric. That's easy as well because the empty relation is anti-symmetric. We want it to be transitive. That's also easy because an empty relation is transitive. We want it to be not comparable, and that's easy too because the empty relation is also not comparable. And we want it to be symmetric, and that's also easy because the empty relation is also symmetric. Oh, we are done. R is just empty. So question number 5 is one of those like super duper easy ones because the empty relation meets all of those requirements. All right, question number 6. Yep, easy money there. So question number 6 is requiring you to evaluate all of these properties given R is a certain thing. Yep. Alrighty. And then Danny presented an example of whether that is comparable, and the answer is it is comparable. Oh, okay. Right. Okay, so I was wrong because when because with 0, 1, it meets both the requirement of 0 relating to 1 and 1 relating to 0. So I was wrong. Good job. So it is not the cardinality of x squared. That is correct. So I'm thinking, what is it then, right? Because certain things are double counted. I think it is x times x minus 1, or the cardinality of x times the cardinality of x minus 1. Nope. Let's see. Would it be the? Okay, think about 4, right? Or think about 2. Okay, so think about when x only has 0, 1. So if it only has 0, 1, then we have 0, 0, 1, 1, 1, and then 0, 1. So it has a cardinality of 3 in that case. So it looks like a triangle thing, which is x, the cardinality of x times the cardinality of x, the whole thing divided by 2. No, it's the cardinality of x times the cardinality of x minus 1, the whole thing divided by 2. Yeah, there we go. So Chris got it. Yep. Is it plus 1 or is it minus 1? Let's see. So it's plus 1. Good job. Yep, it is plus 1. Alrighty. So I can get back on that one to kind of theorize and prove that that is the case. But right now we're going to have to move on because I want to finish all of these questions in today's lecture. Yeah, so Danny, thank you. I was wrong because I just thought, hey, everything needs to pair with everything else, but then I forgot that your one single element is pairing 2 things, so we are double counting in that case. So that's why the division by 2 makes sense from what Chris is presenting. All right. So if it's comparable, it has to be reflexive as well. Yes. But you cannot use not being reflexive to prove that it is not comparable. You still have to present an example of what it is missing. You can use the same example, but you still have to prove that it is. So you cannot just say that. So in other words, for something that is not reflexive, you cannot go to the comparable and just say that since it's not reflexive, it cannot be comparable. That would not be in the format that is needed here in the question. All right, so let's get back to this question here. Okay, so reflexive, we have 0, 0. We do not have 1, 1. So that's that's an easy one. E equals to 1. 1 R1 is false. Does not reflexive. There we go. Next, is it symmetric? All right, 0, 1, 1, 0 is there. Okay, 0, 2, 2, 0 is there. 1, 2, 2, 1 is there. So it is actually symmetric. Okay, so true. So if it is true, you don't have to say anything. It's just that when it's false, you have to tell me why it is false. All right, so anti-symmetric would be an easy one in this case, right? Because you can just pick anything where, because it's symmetric. So if it's symmetric, then you can just pick any tuple that has different values within the tuple itself and use that as your basis for the proof. So we can say when E equals to 0, F equals to 1, then we got ERF and FRE. But when you use it to imply E equals to F, the whole thing is false and thus not anti-symmetric. There we go. All right, is it transitive? And the answer is no, it is not transitive because 1, 1 is missing. But you cannot just say that, oh, since 1, 1 is missing, it is not transitive, because you have to quote the Boolean expression in the quantified expression. So you have to basically tell me what E has to be. So E can be 1, what F has to be, F can be 2, and then what G has to be, which is back to 1. And if E, F, G are instantiated in that specific way, then we have E, R, F being true and F, R, G being true, but that thing implying E, R, G is false and thus not transitive. There we go. Is it comparable? So once again, you cannot use the fact that it is not reflexive to say, okay, so I'm just going to type the wrong answer here and then we'll fix it into the right answer. So this would not be a good answer. Not reflexive, thus not comparable. Okay, because it does not meet the requirement of the format of your answer. Okay, so we don't want to do it this way. So get rid of this. So this means you actually have to give me an example why it is not comparable, which is pretty easy. When E equals to 1, F equals to 1, E, R, F, E, R, F is false, thus not comparable. There we go. All right, so moving on to the next question. So we got 6, and then we have question number 7. All right, so finally we are done with the relations, and now we're down to the CNF, resolution, and stuff like that. All right. So it is known to be true, psi is this thing here, so we want to convert psi into a CNF first. All right, so psi, so I would just copy and paste it like so, and paste it here. All right, so we want to convert this to a CNF. So we'll first get rid of the implication, and this is the way I do it. I just kind of copy and paste whenever I can, and then we change the left hand side to a negation, and then we change the implication itself to a or, like so. So the chances of me making a mistake by copying and pasting and just changing a few operators is lower than compared to just typing the entire thing. So that's the reason why I copy and paste whenever possible. All right, so the next thing we need to do, and I'm matching the parentheses right now. Oh, okay, so I made a mistake here because this entire thing is the left hand side of the implication. There's an overall parenthesis around the entire thing, so this negation is going to the wrong place. It really needs to go here. All right, well, that makes the next step really easy because I'm just going to simplify by getting rid of double negation. So just cross that out, and then we have this thing here. Copy and paste. So I personally would just kind of copy and paste whenever possible, just because this way the chances of making a mistake is lower. Not that it's not possible, it's just lower. All right, so oh, okay. So now we can just use distribution. So we can use the weird distribution that does not exist in arithmetics, right? So let me show you what I mean by that. Okay, so we'll put parentheses around this one first because we're going to distribute the plus r into it. So this plus r is going to be distributed. So cut here, and then paste here, and also paste here. All right. So are there any questions about what I just did? This is the weird distribution that does not exist in normal algebra, but since we're dealing with Boolean algebra, it does exist. Okay, no more questions. All right, so copy and paste again, and we simplify double R to just a single R like that, and we are good. This is a CNF. Now we need to look at phi, which is the proposed theorem. Looks kind of ugly. So we're going to say not phi. This is psi. Okay, let me be clear. This is psi is this. And now we need to look at not phi, but okay. I just said something that's confusingly correct because we are not looking at phi because we need to look at not phi, negation of phi. So the negation of phi is just the negation of this entire thing. So copy, paste, and remember to put a negation ahead of the whole thing. Alright, so now we take this part here, and then we convert that to a CNF. Alright, first thing first, get rid of the implication. So implication becomes a OR with a negation to the left hand side. So you have to make sure that you use the right get to the right term to negate. So I think this time it is correct. Yep. Okay. And then I'm not sure whether we can turn on parentheses matching in Google Doc or not, but I'm not going to spend any time to do it just yet. Alright, so now we have we can potentially apply what was it? De Morgan's law. And I'm just thinking a little bit ahead of time to see whether that's a good idea or not, because we have a disjunction, a negation of a disjunction on the outside, which means once we apply De Morgan's law, it's going to be it will turn the OR into an AND, which sounds like a good idea. Okay, so we'll do it that way. So we end up with the negation of P or not Q, and the negation of P or Q. There we go. So this is De Morgan's law applied to the NOR, which is this is the end of the NOR, and this is the OR of the NOR. So we just applied De Morgan's law. And once we apply De Morgan's law, we can now simplify because the negation of a negation cancels out. So now we have P or not Q, P or Q. All right, looks about right to me. And Nathan is typing something. All right, so now we have to combine those two. And is and, yes. I'm not even sure how do you pronounce double and. That's going to be a tough one. I'll leave it to the linguists. All right, so now we have psi and not phi, and that's what I usually just call the super CNF, which is Q not Q plus not Q or R, P or R, P or not Q, and then P or Q. There we go. All right, so we want to do resolution, okay? And let's see whether we can resolve anything here. Well, we got a few things that we can resolve, right? Because we can see not Q and Q over here. Here's a not Q and here's a Q over here. So we can resolve a little bit. Not phi is just P. Not phi is just P. That is correct. And you can do it by resolution too, because you can see how. Okay, so Chris is right. Let's go ahead and do that. Okay, so if I use this as the connector for resolution, then we end up with okay, I'm just going to copy and paste here. Copy, paste. So we end up with P and as the result of resolving just these two terms. Okay, so P becomes the result of that. But P itself is a dead end because there's no not P anywhere within the CNF, so it's not going to be very helpful. Q and Q and not Q can also cancel out, so we can end up with P or R, but that's already here. In other words, if I resolve this term with this term over here, oh, okay, I take it back. If I resolve this term with this term here, the result is already here, which is P plus R. So that's that resolution is not going to be helpful. Do we have not? Okay, so I'm just going to be systematic here. Not Q or R cannot resolve with P or R, cannot resolve with P or not R. It can resolve with P or Q, but the result of that is already here, which is just P or R. Cannot resolve with P. So the first term is I have just exhausted everything with the first term. Now we move on to the second term. P or R cannot resolve with P or not Q, cannot resolve with P or Q, cannot resolve with P. So the second term is also done. The third term is P or not Q, can resolve with P or Q, but the result is just P, which is already here. And then the second to the last term is P or Q, cannot resolve with P, so we are now done. So as a result, we can now say phi is not implied by psi and thus not a theorem. There we go. Okay. Moving on to question number 8. I'm just looking at the time because I want to kind of time myself. And you guys might be thinking, but Tack, you must be copying from the key of this exam. The answer is no, I'm not actually copying from anything. I'm just doing it on the fly. All right, so same thing, so we look at psi and then we want to convert it into a CNF. So we will take a look at this. Yeah, but sometimes that key is wrong. That's partially why in any class that I teach, I encourage my students to challenge my answers. It's like, how do you know I'm telling you the right answer? Not that I'm trying to deceive you, but sometimes I do make mistakes here and there. So just be careful. Alright, so there we go. We get rid of the implication first by negating the first term. And once again, we have a kind of easy one to do as at least the next step, because we can just simplify by getting rid of the double negation. And then we look at this and let's see. Alright, so one side has RQ, the other side has another conjunction. So what would be the best way to do it? Okay, so we'll go ahead and distribute using the plus thing. Okay. So we copy and paste. Alright, so we'll put parentheses around the not P. And then we'll do the plus RQ to both terms. So we'll have this plus RQ. And then we'll also have this thing plus RQ. and then get rid of the plus RQ here. Alright, so now we can clean up the parentheses a little bit, right? So we can get rid of the unnecessary parentheses here. Alright, this is not done yet, but I can just repeat the process, right? Because within this one here, it just becomes not P plus R, and then have another conjunction with not P or Q. So this one becomes not P or R, not P or Q. And then the other one is kind of the same thing. We can look at Q or not R as one thing, and then distribute the plus RQ over that one term. So we have Q or not R or R as one thing, and then we have Q or not R or Q as the other thing. All right. So technically speaking, this is a CNF already. You can leave it like this, and I cannot possibly take any points off because all I want is a CNF, and this is a CNF. On the other hand, if you simplify a little bit, it can potentially be a little bit helpful. The one term that I can just completely simplify out is this thing here, because not R or R is just one. Anything or one is one, and anything and one is that anything. So this term is completely useless in the conjunction. So I can just do a simplification and end up with something a little bit simpler, like that. And since we have Q repeating itself, Q or not R or Q is really just Q or not R. So since I prefer things to be in the alphabetical order, it does make resolution a little bit easier. So I just leave it as R or Q, and I think that's it. That's the psi. All right, so let's work with not phi. This is phi. We have to negate it first. So doing this is also helping you to understand what you need to do with your homework, right? Because this is kind of like doing your homework a few times. There we go. Okay, so now we have the negation of the whole thing. Oops, just pressed the wrong key. Alright, so the next line is going to start with this. And once again, we get rid of the implication first. Change the implication with or, and negate the left-hand side of the implication. And now we are going to, I think we can go ahead and apply De Morgan's law. So we have the negation of a or, which means we can apply De Morgan's law. So there are a lot of things you can apply. The question is, does it make sense, right? But this time it does make sense, because now we end up with the negation of P or R, P or Q or R, and then we have and then the negation of Q being ANDed with the first term. Okay. So instead of explaining that, I'm going to give you the rule, okay, which is already kind of linked somewhere from my module. That has to do with A plus BC. So I'm using parentheses to indicate the order. This is the same thing as A plus B and A plus C. I'm just using that rule in a nested way. Yep. So you just have to apply it, like a few times until it cannot be applied anymore. All right, so there we go. So this one is an easy one because we have double negation of P or Q or R, but I'm missing a parenthesis. I'm missing a close parenthesis here. There we go. And now that we have the right number of parentheses, we can copy and paste. And just get rid of the double negation. Right, there we go. Get rid of 2 of the parentheses and get rid of 2 of the close parentheses. And now we have a CNF. Alright, so now we have psi and not phi, and that's just a concatenation of what we have here. And by the way, I'm not using a mouse, I'm using a touch point, which looks like an eraser on the keyboard. It's a great pointing device, on the laptop computer, because I just do not like to use a touchpad, because a touchpad, my palm keeps touching it, and then I end up with things that I don't need. All right, so here we have, okay, so this is good. So now we can, so some people may want to do a simplification. No, we cannot even do simplification here. All right, so let's do resolution. And I'm going to do it in, yeah, I will call it eraser. Yeah, so having a gaming mouse, can significantly speed up, how quickly you can answer the questions. So for those of you who can still request things from your parents, you can tell your parents and go like, but in order to take this test, I really need a high-end gaming mouse, because I need to copy and paste and move the mouse a lot. That's going to help improve my grade. So can I buy that $50, $60, $70 mouse? Alright, so getting back to here, we have not P or R, and we want to see what it can resolve with. So cannot resolve with the second one, can indeed resolve with the third one. But once it resolves, it will just become not P or Q, which is already there, so it's not going to help. Can resolve with the fourth term, and once it resolves, it becomes just Q or R, and that's a new term. Alright, excellent. So we'll go ahead and do that one. Okay, so we have copy, paste, and write the new term first, and then I'll highlight where it came from. So the new term is resolving the first with the fourth, so it becomes just Q or R. And then I go back and highlight how we got it. So this is one of the connectors, and this is the other matching side of the connector. So those two terms are being resolved into Q plus R, Q or R. Alright, so let's see, what else can we do? Okay, we are looking at the first one to the last and the second last one. No, they cannot resolve. Now we look at the second one and try to resolve it with the third one. Doesn't work. With this one, it does work, but we just end up with Q or R again, so it's useless. And then the next one is not going to resolve. The last one is not going to resolve. Not R or Q, and Q or R. Okay, now we're moving on to it. Remember, I'm doing it kind of systematically, so I have exhausted everything that can possibly resolve with the second term. So now we move on to the third term. Okay, so now we look at this term and look at the rest of the terms and see which one can resolve with it. So the next one can resolve with it already. We should end up with just P or Q. Okay, so we should do that. Alright, so we just add a new term here, which is P or Q. And the way we did it was to use this R to resolve with that not R to resolve with this R here. There we go. Alright, so we end up with P or Q, and then we look at this, and the Q itself, not Q, that can resolve, so we get not R left. Okay, let me change and get rid of the boldface over here. And let's see, how do I get rid of formatting? I know there's a little eraser thing that's supposed to do it, but where is it? How do I get rid of formatting? There we go. There we go. Okay, excellent. I might have gotten rid of for a little bit too much. This one is supposed to be boldface, and this one is not supposed to be boldface. There we go. Alright, so as I said, there's another resolution that we can do. And let's highlight the entire thing, get rid of formatting first. And then we resolve the third one with not Q itself. So we have just not R left. And that's because of resolving this Q with this not Q over here. There we go. All right. So if we can somehow single out R, then we're all good, right? So I am just gonna cheat here because I can see how to get it done already. So I'm just gonna. It's not considered cheating, because no one. I'm not going to require you guys to do it, in this really systematic way. I do it in a systematic way until I can see a way out. So I can now see a way out because I can now see how I can get R. And to get to that R, which is this R here, I just have to say, hey, this not Q is going to resolve with Q or R. So I end up with this R over here. So one more step and we are all done. So let's go to the next step. Okay, Control C, Control V, and get rid of the highlighting first. And then highlight these two. Okay, we have a 0 as a result of these two resolving with each other. So that means we can now draw a conclusion. Exactly. So Chris is correct. I'm cheating my algorithm. Well, if you guys can see ahead of time, that not R and R is gonna resolve, would cause a contradiction way ahead of me, then good for you. You guys can go for it. I couldn't see it. That's why I just kind of applied the more systematic way until I can see it. Oh, okay, I can see it now. All right, so now we can make a conclusion. Since psi and not phi is false by proof by contradiction sets phi is implied by psi. All right. So phi is a theorem. There we go. All right, looking at the time, I still have 25 minutes. So do you guys want me to go, to get question 9 done, or do you think this is enough for you? Okay, all right, so it's a consensus then to move on to question number 9. And all right, so let's go ahead and do it. Let's do it. Because I think sometimes, I'm not sure whether people get bored and go like, no, don't do this anymore. I got it. So it's hard for me to tell. All right, so copy and paste. And as usual, get rid of the implication. So put a plus here and a negation over here. And I think we are ready to distribute the not Q into the conjunction here. So there we go. So we just have to copy. I have to use a shift enter because with a new paragraph, at least the default end of paragraph spacing is too much. You can go ahead and change the formatting if you want. Just a little bit too lazy to do it. Okay, so we okay, so I have to be careful here because this one did not have parentheses around it, so I have to remember to put parentheses in first before I copy and paste and basically do the distribution. So we do the distribution and distribute over here. I'll do the simplification later. So I usually try to do it as mechanically as possible, and then we do the simplification. Because if I try to combine a few steps into one, I usually end up with a mistake somewhere. So I don't want the process itself to be mistake prone. Alright, so now we're gonna change the ordering because I personally prefer alphabetical order. It just makes it easier to match during the resolution phase. And then this one I can just simplify to not Q or R. Yep, PQR. Yep. I have to remind myself, what is the alphabetical order. There we go. Alright, so this is it. And then we have not phi. So we'll go ahead and just copy the definition of phi, and then we just put the negation on both sides and then do the derivation to C and F. Alright, so phi needs to be negated, and this needs to be negated like that. Alright, so copy, Control Z. There we go. Alright, so as usual, get rid of the implication. So we have an OR here, and then negate the left hand side like so, and we can apply De Morgan's law. So the De Morgan's law is because of this negation being negating this OR over here. So we can use De Morgan's law, and so copy paste. So as you can see, I don't really try to retype things. I try to avoid having to retype things as much as possible. Alright, so De Morgan's law, you can look at it as a distribution of the outside negation. So now the inside are negated, both components are negated. The OR becomes an AND, and then the outer negation is now gone. So that's how I mechanically apply De Morgan's law. And I don't try to combine steps. Okay, some of you may decide to do this, which is okay, but I usually do not perform several steps in one single. I try not to combine steps. Okay, because when I do that, sometimes I make mistakes, and it's harder to backtrack to find out where I might have made a mistake. So I try to really kind of spell it out as much as possible, so this way if I did make a mistake, I can usually back up and find out where I made that mistake. Alright, so I'm not sure what that means. Is it just me, or time seems less? Question mark. Well, whatever works for you. So whatever works well for you, use that method. Alright, so now we have both, and we have psi and not phi, and that's just combining the two CNFs, right? So we take this CNF here, and then we take this CNF here, and then we concatenate the two CNFs to become what I call the super CNF, and that is definitely just my term of referring to the conjunction of what is known to be true and the theorem that you are testing in the process. Alright, so we look at this and go like, can we do any type of resolution? So if you look at R, R has a potential, but we have to single out R and not R first in order to perform that. Well, fortunately, we have not P and not Q over here, which can then be used to single out the Q and the P over here. Potentially. But then we have the concatenation of Q. Alright, so let's single out R first, because that's the easy one to single out. Okay, so let's do that. Alright, so R can be singled out by resolving these two, and then we just have to single out the not R. The not R is not sure whether we can single that one out. Alright, let me take a look at the text channel. Just when pulling out the knot would cancel out an outer knot. right? There any case where doing it in reverse would be beneficial? You save typing. Okay. All right. So now we look at this and see if there's anything quick I can do to get to 0 or get it to a dead end. Well, dead end is not. There's no shortcut to a dead end. Dead end can only be reached when there's absolutely nothing else you can do. But if there's a shortcut to a false, then hopefully we can find it and quickly get there. So to get to the false, I'm gonna need to use. I have to single out not R, and to single out the not R, we need to single out the not P. And here's the not P. So to single out this not P here, we need Q by itself. And so to get Q by itself, I don't see any way to do it. So now we have to go for the systematic way and just resolve everything that we can possibly resolve and then prove that there's nothing else we can do, that we have hit a dead end. I think it's a dead end, but I'm not 100% sure. So we look at the first term and then we look at the second term. Is it resolvable? No. Is it resolvable with the next one here? The answer is yes. And the result of resolving that is going to be not P or R. Okay, so we have not P or R by resolving this Q. This not Q here is going to be connecting with. Wait, hold on a second. What did I say? Right. Not P or R. Yep, there we go. Alright, let me just double check. Not P or not Q or R. Nope, that cannot resolve because we need the Q to be non-negated, so it has to be this one. There we go. Whew, almost made a mistake there. Alright, so these two do resolve, and then we have not P left over, and then we have the or R left over. So that becomes this new term here. Alright, so we look at this and we ask, can we find more things to resolve here? Let's get rid of all the formatting first. Alright, so we are still fixing on the first term, and we have already tried this one. Let's try this one over here. It does resolve because this P can resolve with the not P over here. So now we have P, Q, R, right? So we have not Q or not R. And that is the result of connecting this not P with this P over here. All right. So now we look at this. All right. Let's see. We are still looking at the first term, and then we look at this term over here, not resolvable. Look at this term here, not resolvable. So now we have to look at the second term and see if it is resolvable with the third, fourth, and so on. Okay, so we look at the second term. So we do have an R. We just want to be able to single out the not R over here. To single out this not R, we have to find Q by itself. We're not going to take row today. We'll skip row today. And I apologize for people who are just waiting for me to take row so they can take off. Right, getting back to here. That I just lost my concentration. Okay, so right. So we can look at the second term. So we want to, I think R is promising. So we have to single out the not R. And so I'm looking at all the things that have not R in it. Oh, okay, that's fine. So to single out the not R, we have to get rid of the not Q, which means we have to single out Q by itself. So Alright. I don't see how to do it, so I'm going to do it the exhaustive way. So not Q or R, and Q or R, they do resolve, but they resolve to R and it's already done, so we don't write it again. Not Q or R, P or not R, they do resolve, but they resolve to P or not Q. P or not Q is not here. Okay, so we can add a new term. So we can add P or not Q. Alright, so the way we did that was to use this R here to connect with this R over here. Alright, I'm not sure, I'm not done yet. Alright, so let's do this. Alright, so we are still looking at the second term and try to pair up with the other terms. So this one and this one cannot resolve, and resolve to just not Q by itself. And not Q is not there yet. Okay, so we can resolve these two. So we end up with a not Q by combining or connecting this not Q here with, oh wait, okay, hold on. No. Combining the R with the not R here with the R over here. So we have just singled out the not Q. Alright, so we have R all by itself and we have not Q all by itself. So this is where one of you asked me, I think Danny asked, can we do a simplification? Because since not Q is here, that means not Q or blah 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 is not really useful anymore. And that is true, but if I just want to go with just resolution by itself, then we are not gonna do that. It doesn't hurt, but since the question said only to use resolution without using other techniques, so I'm not going to use the other techniques here. Alright, so we will continue with this. Okay, the second term, and with this term does not resolve. Okay, now we use the third term. So we are focusing on how the third is going to resolve with the fourth and so on. So it does resolve with the next one. It resolves to P or Q, and P or Q is not in there yet. Okay, so we can do that. So we have now P or Q, and that is done by connecting this R with this not R over here. Alright, so copy and paste, remove formatting, and we are still on the third term. So Q or R, not P or R do not resolve. This one and this one they do resolve, and when they do resolve, it becomes R or not R, which is just one, so it doesn't really help. Q or R, and this one they do resolve and they become P or R. So P or R is not here yet, so I have to say P or R. Alright, so that's by resolving this Q with this Q, not Q over here. There we go. Alright, let me double check. So we have P coming from this expression, and then we have R coming from this expression. So that is correct. Alright. And I can see some people are dropping off already because this is boring. Alright, so we are still looking at the third term compared to the not Q, and that will single out an R, but R is already here, right? Yeah, R is already here. So it's not a new term. So we look at this term with this term over here. Doesn't resolve. We look at that term with this term, it does not resolve. So now we focus on the fourth term. The fourth term does resolve with R. We end up with just P, and P is not there yet. Alright, so let's add P, and that's from resolving this not R. This is one of the connectors with this connector over here. So we end up with a P. And continuing, so we want to look for things that have either a not P or R. So here's a not P, and then we end up with R, not R or R. That's just one, so it's not useful, it's not productive. Let me just highlight here which one I'm comparing with others. So we are done with this one. We are now looking at this one. It does not resolve. With this one, does not resolve, does not resolve. The rest, it does not resolve. With this one, it does resolve, but we already have P out here, so we are done with that. So now we move on to the R. It results with not R, so we can single out a not Q, but not Q is here already. Let's see. There's no other resolution available, so we look at this term and see how it resolves with the rest. This one does resolve with the next one. We end up with not P or not Q. Not P or not Q is already here, so it's nothing new. So we're not going to write it down. So what about this one with the next one? They also resolve. They also resolve to R or not Q. R or not Q is already here, so it's nothing new. And with this one here, it does not resolve. With this one here, it resolves to aha. Okay, wait. Okay, maybe not. Okay, with this one, it resolves to Q or R. Q or R is already here, so it's nothing new. And with this one, it resolves to R itself, which is already here. And then with the last one, it resolves to R also. Okay, so we have exhausted that one. Yep. Well, this is also why it can be done using a program, right? This is very procedural. So now we try to pair this one with the rest. Does not resolve with the next one. Does not resolve with the one after that. Does not resolve with. It does resolve with this one, but does it get us anything new, right? So the Q and the not Q are cancelled out. So we end up with P or not R. So P or not R is already here, so it's not productive. And then with this one, they do resolve. We end up with P or not Q. So P or not Q is already here, so it's nothing new. Let's see, and then the rest, they do not resolve. And then we look at this one, and then we try to. It does not resolve with the next one. It does resolve with the one after that. We end up with just P, which is already here. With this one, it does not resolve. With this one, it does not resolve. Okay, so I think we're almost there. Not Q does not resolve with any. Oh, it does. Okay, it resolves with the one right next to it, but it ends up with a P, which is already here. Does not resolve with anything else. And then the rest, these three, they do not resolve among themselves because they're all non-negated terms. So at this point, I can make a conclusion and say no further resolution is possible. Okay, so psi and not phi is not false. And as a result, thus, phi is not a theorem. Oof, okay, so that took a little bit of time. And I still have 3 minutes left, 2 minutes ish. All right. Not fun is true. All right, so that's it. Okay, this is the entire test. So you have time, right, to develop your skills and tools to kind of get through this stuff in a more efficient way. Now I just did it in a very systematic way. But in order to show that something is not a theorem, you have to get it to the point where there are no further resolution available. If you resolve any two terms here, it's going to be something that's already in the CNF. So that's the thing. Alrighty. Well, we are going to have to do this using punch cards. Copying and pasting, it makes it too easy, so we have to do it using punch cards. Exam 2 is 1 week from today. That's the usual way that I do things, so I believe it is April 6th. Yes. So that would be the date of exam 2. So let me type first, affirmative. I think I try to pre-answer the question from Chandra early on in the lecture. I cannot guarantee anything about the format. All I can say is you need to know about relations and also propositional logic, CNFs, resolution, proof by contradiction. So I can only confirm the scope, but I cannot confirm anything about the format. So you just have to be kind of flexible when it comes to applying the knowledge within that scope. Alrighty. We got 10 more seconds. Exactly. So read the questions carefully. The first thing is to read the questions carefully, understand what it's asking. Now, if you're not clear what it is asking, or if you think there are several ways to interpret what it is asking, confirm with me. Okay, so always confirm with me if you have any doubt about your understanding of what the question is asking. So that is important. Other than that, it really is, just, once you have the understanding of the material, it is just, how we're going to apply that knowledge, to solve, a question, to solve a problem that's presented to you as a question. So, all right. Alrighty. Now, I do have to say, with respect to, this stuff here, in terms of CNF, proof by contradiction and resolution, there's probably not a whole lot of variation, of how a question can be asked in a format that, I can give, each person in the class a different question. So, but in terms of relations, it's really boiling down to, do you understand those concepts, right? So I can potentially, okay, this is potential, there's no guarantee, okay? So I can potentially give you a relation that does not meet certain requirements. So kind of look at it as a special version of like question 5, okay? So the requirement is I need blah, 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 okay? But I give you a certain relation R that is not meeting all of these requirements. And I might ask you, okay, what is the minimum change that you can make to an R that is already given to you so that it meets all of the requirements? So that potentially is a question, right? One form of a question that I can ask. So I can only tell you, that, other than potentially, yes, I can give you a question in that format, but it really tests the same thing, right? It really just kind of boils down to testing, okay, do you know what is reflexive? Do you know what is anti-symmetric? Do you know what is transitive? And so on. It's just, the format is asking you to reflect your understanding in a different way. So instead of asking you to give me an R and it's not given to you, just give me a R to meet all the requirements, I might give you an R that does not meet all the requirements, and your job is to make it meet all the requirements by removing and adding new elements. So that's potentially one type of question I can ask. But I cannot guarantee you, anything about the format, just because, I have not, come up with the format yet. This is from last semester, and that's basically what it is. It is what it is. This is the exam from last semester, and I cannot guarantee in terms of the format, how much it's going to resemble yours. All right. Yeah, that's not necessarily true. Okay, because just because I'm going to teach in person doesn't mean I'm not going to use Discord. So I can still be, we can be in the same classroom in real life, face to face, and you can still use Discord to send meme to the entire class. I don't see why not. Okay, could there be mixing of the different topics? um, as some other students may say, don't give tech ideas. Um, I, in some tests, yes, I do. I do kind of mix ideas. So there's this concept, and that concept, and I just kind of go like, hey, I can make a question that can combine the two different kinds of concepts. But I'm not gonna make those like the exclusive type of questions, because that would be that would be disastrous, for people who understand one really really well but not quite the other one. Because when I combine those two, that means people who understand only one of the two is not gonna do really well in that exam, in that kind of question. So I will try to refrain from asking those kind of questions. Yeah, I can see how it can be done, but it's not. It's gonna look very artificial. So, any other questions? Does Luke want to give me any more ideas? But but I think it's really important that you understand the concept, not to be over prepared in terms of the steps, the procedures, and the process. The procedure and the process, I think, should be derivable when you see the question. The knowledge that you gain and the depth of the knowledge, that is how you prepare for the test, is to increase the depth of the knowledge. So I can that's how I look at it. That's how I look at any exam. Whether I'm the one giving the exam or whether I'm the one taking the exam, is the depth of the knowledge is actually going to be important. Because once you have that depth of knowledge, then the application of that knowledge can be generated on the fly. If there's no previously known steps or procedures or process to do something, by using the in-depth knowledge of the subject matter, you can come up with those steps like on the fly. And kind of that's what problem solving is about. So, but I will try to make sure that it's not too much. Alrighty. Oh. Okay, so I got a DM. I'll address the DM later. So, are there any other things I can answer with in the text channel today? Now, we do have one more lecture before the exam, which is next Monday. And over the weekend, when you guys are preparing for the exam, when you're studying, if you have any questions, go ahead and just ping me. Okay, so I can guarantee to reply, within a day, during the week, and within 2 days, over the weekend. So I think that's going to be important. So go ahead and study. Okay, make sure that you really understand the concepts, and that's the best way to get ready for a test. All right. So Philip is still typing. All right. Yeah, sure, absolutely. Um, all right, so I guess people are dropping off. I'm going to stop the screen share, but I will stay on the text channel in case people have additional questions or points. You can DM me if you don't want to use the class channel too. So take your pick. All right, you guys have a nice weekend too.